Bismillahirrahmanirrahim. Hello, my dear students. I hope you are having a nice day. I welcome you all in class of O-level mathematics. Our discussion is continue on probability and combined events. In today's lecture, we will discuss the concept of tree diagram. So, firstly, we discuss what is tree diagram, why do we use tree diagram, what is the purpose of tree diagram. So, let us define tree diagram. In previous lecture, we have drawn the sample diagram, sample space diagram. We have write all possible outcome of an experiment in the form of sample space diagram. So actually, tree diagram is another way. This is an other way. Another way to represents represents all possible outcomes of an experiment, of a random experiment. A random experiment in the form of tree is called tree diagram. So sample space can also be formed by making tree diagram of all possible outcome of an experiment. Let us elaborate the concept of tree diagram with the help of some examples. Suppose we have to make tree diagram in case of two coins. In the set notation, when you toss two coins, your sample space is head, 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 tail, tail, head, tail, tail. So these are the four possible outcomes for a sample space of two coins. Let us make T diagram of this sample space when you toss two coins. So we start from the T diagram of a single coin. When you toss a single coin, there are the two possible outcomes. Either it will be head or it is tail. This is the tree diagram of a single coin. Now let us make the tree diagram of two coins. So let us firstly we will write the sample outcomes of a single coins. This is the first outcome. This is the first outcome. First outcome of first coin. Now from here, we will draw the two branches for the second coin. On the second coin, there are also two possible outcomes. Either it will be head or it will be tail. So from here, we have two possible outcomes. When you combine both of these outcomes, the first outcome is head, head. The second is head, tail. Similarly, if you write the second outcome of, this is the second outcome of first coin. The second outcome of first coin is tail. Now, when you join this outcome with the other, with the outcomes of second coins, which are head and tail, now from these branches you have these possible outcome: tail, head, tail, tail. So you can notice that from this tree diagram, these are four possible outcomes. You may also join these separate diagrams in a single diagram like this. These are the two possible outcomes of a single coin, and from each branch these are further two possible outcome of the second coin here, head tail head tail. So from here the first possible outcome is head head, the second is head tail, the third is tail head, the last one is tail tail. So you can make the T diagram by any way. You can join the complete diagram in a single diagram, or for your convenience you can make the tree diagram for each case separately. So let us now we make the tree diagram for three coins. When you toss three coins, the total possible outcome you know are given by 2 raised to power 3, which is equal to 8. Here I write the first possible outcome of a first coin. Now there are the two possible outcome on the second coin, which are head and tail. Then again for the third coin there are also two possible outcome, head and tail. Similarly here, head and tail. Now when you join from the first branch, head head head, the first possible outcome on three coins is all of these are head. From the second branch these are head head tail. The third branch gives us head, tail, head, and the last branch gives us head, tail, tail. Similarly, if you write here the second outcome of first coin, that is tail, then on the second coin both outcomes are either it will be head or tail. Similarly, the third coin has outcome head and tail, head and tail. Now if you make the fifth one outcome is tail head head by joining this tail with these two heads. Similarly, if you move from this branch tail head to tail, this gives us tail head tail. This branch gives us tail tail head, tail tail tail. So you can see here this diagram is look like as a tree, and this tree has a further, these are the branches of this tree. So that's why this diagram is known as tree diagram. The tree diagram is actually used to draw all possible outcome, to find all possible outcome of a random experiment. Further, it is very helpful in the case when you have when you have questions, especially in form of numbers, like if we have to find how many two digits number, how many two digits numbers can be formed by using digits, 1, 2, 3, 4. The first case is when no digit is repeated, no digit is repeated, mean to say repetition of digit is not allowed here. And the second case is digits may be repeated. Mean to say repetition is allowed. Repetition of digits is allowed here. is allowed. So we have to find all of the possible numbers that you can form by using these digits with the help of tree diagram. Given digits are 1, 2, 3, 4. We have to form two digit number like this. There will be some digit here, like this is 4, and there is 1 here. So the number is 41. So how many numbers you can form, and also you have to find all of the numbers in both of the cases. So if your first digit is 1, then this is first case in which repetition of digit is not allowed. Then your second digit is maybe 2 or 3, or it will be either 4. So from here you have three numbers: 12, 13, 14. Similarly, if your starting digit is 2, then your second digit uh, is 1, or it may be either 3. You cannot write here 2 because we have already been used 2 here. So repetition is not allowed. So you cannot repeat any digit again. And the last digit is 4. So from here, the numbers are 21. Number is 21, 23, 24. Similarly, if you start your number from 3, then at second place you can write 1, 2, 4. Number are 31, 32, 34. If your starting digit is 4, then second place you can write 2, 3. Your number are 41, 42, 43. So there are total 12 number in this case that you can form here. Now when repetition is allowed in case 2, when you can repeat any digit. Suppose if your starting digit is 1, then again you have now 4 possible outcomes, because you can write here again 1. Repetition is allowed, so you can write here 1 again. 2, 3, 4. In this case, your number is 11. Now you can see both of the digits are repeated here. This is 12. From here you have 3, 1, 13, and from here you have 14. If your starting digit is 2, then at the second place you can write 1, 2, 3, 4. All of the digits you can use. So this number is 22, 21, 22. From here 23, 24. Similarly, you can make all of the numbers in other cases, like when you start number with 3, your number is 31, 32, 33, 34. These are the 4 numbers when your starting digit is 3. If your starting digit is 4, now numbers are 41, 42, 43, 44. So the total numbers in this case are 16. Now we make us another more complicated example. Now I have to make a 3-digit number. I have to make 3-digit number. 3-digit number. Given digits are 0, 1, 2, 4. Case 1, repetition is allowed. Repetition is not allowed. Case 2, repetition of digit is allowed. Now we have to find all of the numbers that you can form here. As we have to form a 3-digit number here, so this is not possible that 0 comes at the first place. 0 never come at the first place. This is not possible. For example, if you write number 0, 0, 12. This is not a 3-digit number. This is only a 2-digit number, and it is 12. So it cannot be considered as a three-digit number. So this is not possible that your starting digit is 0. So we cannot use 0 at the first place. So there are the only three possibilities for the first place. Uh, in case of when repetition is allowed and not allowed, you cannot start your number with 0. So there are the only three possibilities. You can start your number either with 1 or with 2 or with 4. Suppose we start with number 1. Now, at the second place, you can write 0, you can write 2, or you can write 4. Now, we have to make a three-digit number, so there will be an third branch also. As we have already been used 1 and 0, so at the third place, you can use only 2 or 4. In this branch we have already been used 1 and 2, so at the third place you can use only 0 and 4, the remaining digits. Similarly, at this branch you can use only 0 and 2, the remaining digits. So from this tree diagram, the required number are 102, 104, 120, 124, and from here your number are 140, 142. Similarly, if you start your number with 2, your starting digit is 2. Now at a second place, you can write 0, 1, 4, the remaining digits. Now at the third place, as we have already been used 2 and 0, so 0 and 2 cannot be used at third place. So the remaining digits are 1 and 4. Similarly, from this branch, 2 and 1 have been used already. So the remaining digits are 0 and 4. And here the remaining digits are 0 and 1. So now possible numbers are 201, 204, 210, 214, 240, 241. I hope the last case, when your starting digit is 4, you can make by yourself. Now we discuss the second part, in which repetition is allowed. Repetition is allowed. Our digits are 0, 1, 2, and 4. Again, you cannot start your number with 0. Either it is the case of repetition or not repetition. You can start your number with 1, 2, or 4. If I start my number with 1, now there are 4 possibility for me, because repetition is allowed. So any digit again we can use again. So at a second place I can write 0, 1 again, 2, 4. I can use again 1 because repetition is allowed. So there are the 4 branches in each case. From here there are also 4 branches. There will be also 4 branches. You can use any of the 4 digits, 0, 1, 2, 4, and from here you can again use any digit. So there are the 4 branches here, 0, 1, 2, 4. Lastly here you can use 0, 1, 2, 4. And from here you can again use all of the digits. So again there are 4 branches, 0, 1, 2, 4. So when you start your number with 1, There are total 16 numbers that you can form from here. First number is 100, the second is 101, third is 102, the fourth one is 104. From here, your number is 110, 111, 112, 114. And from here, your number is 120, 121, 122, 124. Lastly, from here, 140, 141, 142, 144. So there are the 16 possible number when starting digit is 1. Similarly, when your starting digit is 2, then again there are 16 number. When your starting digit is 4, then again there are 60 numbers. So total number in this case are 48. Actually, this question is also related to permutation and combination. In permutation and combination, we can easily find the total number of digits. But permutation combination does not tell us all of the numbers. It just tells us how many number you can form. Our digits are 0, 1, 2, 4. If we have to make three digit number here, your starting digit is not 0. So there are only possible 3 numbers that you can write here. So there are the 3 possible ways to writing any number at this place. Now you can include here any of the number. So there are again 3 digits I have, and at the last place I have only two choices to write any number. So in case when you cannot repeat, when repetition is not allowed, the total possible numbers are 18. Now, in case when repetition is allowed, the first digit cannot be 0, so there are only 3 possible outcomes, 3 possible ways to write any number. But at the second place, you can write any of the 4 digits, 0, 1, 2, 4, in case of repetition. So there are the 4 possible ways here. Similarly, here again you have a 4 possible ways. If you multiply all of these possible ways, there are total 48 ways, and you can verify that we have find 48 total numbers. So in this basic lecture, actually I have discussed the concept of tree diagram. Inshallah, in the next lecture I will discuss more question related to tree diagram available in your textbook. So if you find this lecture is helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.